All right, here's just a quick review of complex numbers. And so historically, obviously, this is a problem. 3 times 3 is 9, negative 3 times negative 3 is 9. And so that's been undefined. And so what mathematicians did is they're like, all right, let's just separate that out. And let's define the square root of negative 1 as an imaginary number. We'll call it I. And then we could take the square root of this part, which is 3, and this part is still the square root of negative 1, but we'll bring it out as an I because that's how we defined it. And then we can do math. And so if you think about that, then I squared would be if I square both sides, and squaring undoes square rooting. So that's going to be a negative 1. And I cubed would just be an I squared with another factor of I. Well, this guy's a negative 1, so this would give me the opposite of I. And if I have I to the 4th power, that's just I squared times I squared, and a negative 1 times a negative 1 is a positive 1. So we have this nice little pattern where it starts out with I, and then it goes to negative 1, and then it goes to the opposite of I, and positive 1. And then if you think about it, that's going to continue, because if I give you I to the 5th, that's just going to be I to the 4th, which is 1, times another I. So we get back to I. If I give you I to the 6th, that's just going to be I to the 5th, which is I, times another I, which is I squared, which gets me back to negative 1. I to the 7th is just going to be I to the 6th, times another I, which again is the opposite of I. And I to the 8th is negative, or I to the 7th, which is opposite of I, times another I, which gives me a negative I squared, which would be a negative times a negative is a positive 1. And so you can see this pattern goes in 4s. And so that's kind of handy, because if someone, gives you I to the, I don't know, 28th, you're like, oh, that's a multiple of 4. That is awesome. It's going to be 1. Say someone gives you I to the 213th power. All right, you're going to look at that and try to get it into a multiple of 4. So obviously 200, but then 13, that 4 would go in there more. So you think, okay, let's see, how about 212? And then there would be, what, 1 I basically left over. That adds up to 213. And again, you can divide, and 4 goes in there 5 times, and then there's 12 left over, and obviously 4 goes in that also. So this part of this is going to be 1, and then we have an I left over, so the answer is I. So that's kind of how you can simplify powers of I. You just try to get them into a multiple of 4 and see where they land. So again, I to the, 11th, I'd look at that and be like, okay, I to the 8th plus what, 3? So I to the 8th would land here, and then 1, 2, 3. So that would end up having an answer of the opposite of I. Now, with these, you can do math. I mean, you can add them just like algebra, So we tend to like A plus BI form, meaning the real number part here and the imaginary part here. So sometimes we add these numbers. But again, it's just algebra. It's like collecting like terms. So 2 plus 4 is 6. Have 3, 8. That's a negative 5i. And notice how it's still in that same form. We have the real number part and the imaginary part. You can multiply them. Right? And you can do FOIL or distributive property twice, however you like to multiply. But first, outside, inside. Last is what? Negative 15i squared. And then the difference with imaginary numbers and complex numbers versus, say, just doing algebra is that you always have to look for I squared. So I squared has a value of a negative 1. So that would be a positive 15. So I can cross that off and instead put a positive 15. So my positive 15 and my 8 gives me what? 23. And then I 10 have that, so plus 2i. And again, you can divide them using conjugates and all sorts of things, but this is kind of just a quick review.